Hello students, I am Mohammad Rizwan. Today we are going to learn rational numbers. Children, let us recall the different types of numbers which we have already learned in our earlier classes. When we want to count, it is natural to start with numbers 1, 2, 3, 4 and 5, isn't it? These are all called counting numbers or natural numbers, and their collection is denoted by n. The use of 3 dots at the end of the list is a notation to show that list keeps going forever. The natural numbers can be visualized as a ray marked with these numbers. Consider the situation that yesterday my purse had money, say rupees 80, but today the purse may be empty. How many rupees are there in the purse now? How to denote this emptiness? Here comes the concept of zero, which evolved to symbolize the idea of emptiness. The concept of zero, though quite natural now, was not normal to early humans. Only after hundreds of years, people started thinking of it as an actual number. The difficulty was solved when the Indian mathematicians provided the symbol for zero. The natural number system, with this additional number, 0 became whole numbers. The whole numbers can be visualized now as follows. The system of whole numbers is denoted by W. Even 0 was not sufficient to solve all problems. Think what happens when 4 is taken away from 6. Draw a number line up to say 9, mark 6 by a dot on it. We know that to subtract 4, we need to go 4 steps to the left side from 6. We will land on 2, and so the answer is 2. But what will happen if we want to subtract 6 from 4? This situation is where humans needed and created negative numbers. But how can a number be negative? Simple. Just think of them as numbers less than 0. Including the negative integers with the whole numbers, we get the list of numbers called the integers. The integers consist of 0, the natural numbers, and the negatives of the natural numbers, and it consists of a list of numbers that stretch in either direction without end. The entire collection of integers is denoted by Z. Mathematics alive, numbers in real life. If an orange is peeled off and 8 carpels are found, then one carpel represents the rational number 1 by 8. Finding the square root of numbers in the form spiral using the Pythagoras theorem from geometry. After the completion of this lesson, you will be able to know learning outcomes. to understand the necessity for extending fractions to rational numbers. To represent rational numbers on the number line. To know that between any two given rational numbers, there lies many rational numbers. Keywords from this lesson: numbers, integers, decimal numbers, negative and positive numbers, numerator and denominator, addition, subtraction, multiplication and division, rational numbers. Even after coining integers, one could not relax. 10 divided by 5 is no doubt fine, answering 2, but is 8 divided by 5 comfortable? Numbers between numbers are needed. 8 divided by 5, seen as 1.6, is a number between 1 and 2. But where does minus 3 divided by 4 lie? Between 0 and minus 1. Similarly, where do you find minus 12 by 5 on the number line? Between minus 2 and minus 3. Thus, a ratio made by dividing an integer by another integer is called a rational number. Remember, we should not divide by 0. Formally speaking, a rational number is a number of the fractional ratio form a by b, where a and b are integers and b not equal to 0. The collection of all rational numbers is denoted by q. Non-negative rational numbers may be thought of as fractions. They can also be expressed as decimals and percentages. Rational numbers on a number line. Locating rational numbers on a number line is an important skill. For example, to represent the number minus 3 by 4 on the number line, minus 3 by 4 being negative would be marked to the left of 0, and it is between 0 and minus 1. We know that the integers 1 and minus 1 are equidistant from 0, and so are the numbers 2 and minus 2, 3 and minus 3 from 0. This concept remains the same for rational numbers too. Now, as we mark 3 by 4 to the right of 0 at 3 parts out of 4 between 0 and 1. The same way, we will mark minus 3 by 4 to the left of 0 at 3 parts out of 4 between 0 and minus 1 as shown below. Similarly, it is easy to find minus 3 by 2 between minus 1 and minus 2, since minus 3 by 2 is equal to minus 1 by 2 p. Now, on the following number line, what rational numbers do letters a and b represent? You will now be able to say easily the rational numbers marked by a and b on the number line as shown above. Isn't it? Here, a represents the rational number minus 4 by 7 of minus 32 by 7. and B represents the rational number 3 by 5 of 18 by 5. The decimal representation of a rational number. A rational number can be nicely represented in decimal form rather than in the usual fractional form. Given a rational number in the form a by b, where b is not equal to 0. Just divide the numerator a by the denominator b, and we can see that it can be expressed as a terminating or non-terminating recurring decimal. Example: write the decimal forms of the following rational numbers. First one, 1 by 4, and second one, 1, 3 by 20. Let's solve the first one. Solution. To find the decimal representation of 1 by 4, we multiply into 25 in the denominator and into 25, and that's how we get the decimal representation for 1 by 4, which is 0.25. Second, 1, 3 by 20. We first multiply 20 into 1, and then we add it to plus 3, so that we can get it in a proper fraction form, which is 23 by 20. And then to find the decimal representation of 23 by 20, we multiply 5 in the denominator and numerator, and we get the answer. Positive and negative rational numbers. Rational numbers may be classified as positive and negative rational numbers. If both the numerator and denominator of the fraction representing a rational number are of the same sign, then the rational number is positive. For example, numbers like 3 by 4, minus 11 by minus 6, etc. are positive rational numbers. If either the numerator or the denominator of the fraction representing a rational number is negative, then the rational number is negative. For example, numbers like minus 3 by 4, 11 by minus 6, etc. are negative rational numbers. 0 is a rational number which is neither positive nor negative. Equivalent rational numbers. We know how to write equivalent fractions when a fraction is given. Since a rational number can be represented by a fraction, we can think of equivalent rational numbers duly obtained through equivalent fractions. Suppose a rational number is in fractional form. Multiply its numerator and denominator by the same non-zero integer to obtain a rational number which is equivalent to it. Example. In the above example, we are supposed to find the numerators and denominators. Solution. The first one we have, which is 7 by 3. We have to multiply its numerator and denominator by the same non-zero integer to obtain a rational number. Seven into 3 by 3 into 3, which is equal to 7 into 3 gives us 21, and 3 into 3 gives us 9, which is equal to 21 by 9. Next, we have 7 by 3, which is equal to 7 into 7. We can see that we have 49 above. In the same way, we multiply the denominator into 7. So we get the answer as 49 by 21. Next, we have 7 by 3 is equal to 7 into minus 3, as it is shown. The minus sign has been given to minus 21. In the same way, we multiply into minus 3 in the denominator. So we get minus 21 by minus 9. Seven by 3 is equal to 21 by 9 is equal to 49 by 21 is equal to minus 21 by minus 9. Rational numbers in standard form. Observe the following rational numbers: minus 3 by 7, 1 by 6, minus 4 by 13, minus 50 by 51. Here we see that the denominators of these rational numbers are all positive integers. 1 is the only common factor between the numerator and the denominator of each of them. And the negative sign occurs only in the numerator. Such rational numbers are said to be in standard form. A rational number is said to be in standard form if its denominator is a positive integer and both the numerator and denominator have no common factor other than 1. If a rational number is not in the standard form, then it can be simplified to arrive at the standard form. The collection of rational numbers is denoted by the letter Q because it is formed by considering all quotients except those involving division by 0. Decimal numbers can be put in quotient form and hence they are also rational numbers. Example: mark the following rational numbers on a number line. First one, minus 2 by 3. Solution: minus 2 by 3 lies between 0 and minus 1. The unit part between 0 and minus 1 is divided into 3 equal parts and the second part is taken. Second, minus 8 by minus 5. Minus 8 by minus 5 is equal to 1 of 3 by 5. 1, 3 by 5 lies between 1 and 2. The unit part between 1 and 2 is divided into 5 equal parts and the third part is taken. Rational numbers between any two given rational numbers. Consider the integers 4 and 10. We can locate 5 integers 5, 6, 7, 8 and 9 shown in the dark dots between them, isn't it? How many integers can you find between 3 and minus 2? Are there any integers between minus 5 and minus 4? No is the answer. This shows that the choice of integers between two given integers is limited. They are finite in number or maybe nothing between them. Let us think about what will happen if we consider rational numbers instead of integers. We will see that we can have many rational numbers between any two rational numbers. There are at least two methods to find more rational numbers between any two rational numbers. Method of average. We know that the average of any two numbers always lies in the middle of them. For example, the average of 2 and 8 is 2 plus 8 by 2 which is equal to 5. And this 5 lies in the middle of 2 and 8 as shown in the following number line. We use this idea to find more rational numbers between any two rational numbers. Method of equivalent rational numbers. We can use the idea of equivalent fractions to get more rational numbers between any two rational numbers. This is clearly explained in the following illustration. Let us now try to find more rational numbers, say between 3 by 7 and 4 by 7, by the following visual explanation on the number line. If we get the multiples of the denominator of the equivalent rational numbers, the easy one will be to multiply by 10. Then we can insert as many rational numbers as we want. We shall write 3 by 7 as 30 by 70 and 4 by 7 as 40 by 70. And see that there are 9 rational numbers between 3 by 7 and 4 by 7 as given in the number line below. Now if we want more rational numbers between say 37 by 70 and 38 by 70, we can write 37 by 70 as 370 by 700 and 38 by 70 as 380 by 700. Then again we will get 9 rational numbers between 37 by 70 and 38 by 70 as 371 by 700, 372 by 700, 373 by 700 and so on. The following diagram helps us to understand this nicely with a magnifying lens used between 0 and 1 and further zoomed into the fractional parts also. Thus, we can see that there are an unlimited number of rational numbers between any two given rational numbers. Points to remember. A number that can be expressed in the form a by b, where a by b are integers and b not equal to 0, is called a rational number. All natural numbers, whole numbers, integers and fractions are rational numbers. Every rational number can be represented on a number line. 0 is neither a positive nor a negative rational number. A rational number a by b is said to be in the standard form if its denominator b is a positive integer and HCF a comma b is equal to 1. There are unlimited numbers of rational numbers between two rational numbers. Thank you for watching.